Hello and welcome to my YouTube channel. Today I'm going to be treating differentiation part 3. Like my last session we had differentiation part 1. This is differentiation part 3. So first of all, today I'm going to be teaching chain rule. We're going to be solving problems on chain rule. Remember, in my first class I gave rules to differentiation that we'll be using now. We'll be applying most of them here. So if you didn't get the video, you didn't check the video, go to my first video on differentiation. That's differentiation part 1. And check it, you see the rules I gave. So we're going to be applying this even while solving for this rule. So first of all, what is our chain rule? Our chain rule states that if y is equals to u, if y is equals to x, and x is equals to u, then y is equals to a function of u, and if that's a function of u, or you can put the prime here anyway, equals to derivative function of u times the derivative function of x. So what do we mean by that? We are saying dy dx of y equals to u when x is equals to u means dy dx is equals to y du times du dx with respect to u. So this is with respect to u. So first of all, the first thing we're going to do now is to solve. If we are given a question now, let's use an example to show you how this works. Let's say y is equals to x plus 3 raised to power x minus 3. Sorry, that's more complicated. Let's just start from something really easy. I said y is equals to x plus 3 raised to power 5. So now, if you are saying this, you can't use first principle to solve this because it's going to take a whole lot of time. You can actually do it, but before you even start, I'm sure the time is going to be up. So this is how we go about it, using chain rule. So using chain rule, like I said, y is equals to x as a function, then y and x is also equals to u. Therefore, the function of u multiplied function by the function of x with respect, the function of u with respect to x, yeah, something like that. That's what I mean, chain rule. So using chain rule, let's say u is equals to x plus 3. We want to separate this x plus 3 from this so that we don't have to start expanding it. So we separated it now by saying u is equals to x plus 3. So we want to find the function of u only first. The function of u only, yes, with respect to x. So first of all, we're going to do du dx. So differentiating this alone, what are we going to have? We're going to be having 1. Why? Remember those rules I gave in the first video. If y is equals to x, dy dx is equals to 1. If y is equals to a constant, that is any number, you see, if y is equals to x, dy dx is equals to 1, that is why we have this one here. So now, what happened to this tree? Yes, if y is equals to any constant 2 at the same time, that constant automatically becomes 0 when you're differentiating it. So dy dx is equals to 0. That's the rule we use here. So we know that this is automatically 0. So we'll go to the next. We're going to find dy du. So we're going to find the function of y now. Now that we have found the function of this only, we're going to find the function of the entire thing now with respect to u. So now we know that y from here, we know that y now in this case becomes u. U raised to power 5. Why? Because u is already equals to this. So let's substitute u into the equation. We know that u is equals to y is equals to u raised to power 5. And if that's the case, dy du differentiate this. We're also going to differentiate this with respect to u. Differentiating this, we're going to have 5u, that is 5 times u, with 5 minus 1. Remember another rule. If y is equals to ax, that's the first rule of differentiation. Then if y is equals to x raised to power n, then dy du dx, or anything else is x that is here, is going to be nx raised to power n. It's going to be nx raised to power n minus 1. That's the rule. So by bringing down the 5, like here where the n was brought down, and we're going to minus it by 1. So that we're going to have, we're going to be having 5u raised to power 4. That is the function of y with respect to u. So now that we have gotten this, let us now substitute back our value for u, because of the question was to find dy dx of this. So we're going to substitute back the function of u, or the substitute back what u is equal to back into the equation or whatever. Sorry, going to be having 5 brackets x plus 3 raised to power 4. That's the question. That's the answer. So we know that dy dx is equals to this. So what are we going to do now that we're getting this? Our answer is going to be, like I said, the chain rule. Dy dx, bring back the formula into here, is equals to dy du multiplied by du dx. So what are we going to have? Dy du dx, is equals to dy du is what? 5 raised to power u, 5 times u raised to power 4 multiplied by, what's du dx? 1. So what are we going to have? Dy dx is equals to 5 raised to power 4. So we're going to substitute the value of u back into the equation, because we're asked to find dy dx, not dy du. So dy dx is equals to 5 brackets x plus 3 raised to power 4. And that's our answer. You see, I found the differential value of this using chain rule. So let's try another question before we go. If y is equals to x minus 6 or bracket raised to power 7, find dy dx. So like I said, u is equals to what? We're going to let u be equals to this value. Wherever we see x, we're going to equate it to u. That's going to be x minus 6. Yes, and then the differential value of u dx is going to be what? 1. So that we're going to be having u is equals to, sorry, dy dx now, because we know our y is now equals to u raised to power 7 because of u is now x minus 6. So the differential value of y with respect to u now is going to be what? 7 times u raised to power 6. So we now know that from our formula, chain rule formula, we know that dy du times dy du dx is our dy dx. So definitely we're going to be having 7u raised to power 6 times 1. So our answer is 7u raised to power 6. But in dy dx, we have to find function of y with respect to x, so we have to remove this u, and that u is equals to x minus 6. So we're going to be having 7 brackets x minus 6 raised to power 6, and that's our answer. So thank you for joining me today again. I'm Chill Math, and I solve questions the most easiest way possible. So don't forget to subscribe and like and follow up on my channel for more videos. In the next 2 days, we're going to be doing differentiation part 3. There I'll be teaching product rule and quotient rule. Then we go into more solvings and calculations that will help you build your understanding on differentiation. So goodbye, thank you, see you another time.